All right, let's look at the homework 8.1, problem number 8. All right, so we want to use the Simpsons rule with n equals 10 to estimate the arc length of this given curve from 0 to 6. All right, so let's do that. All right, so I'm going to open up Geogebra. All right, so I'm going to define A is 0. All right, hit enter. And B is 6, hit enter. And then we can define, oh, actually n is going to be 10, so maybe I'll just put that there, n equals 10. All right, then we can define delta x. Oh, so let's see, we can go to Greek letter, delta. All right, delta x is b minus a divided by n. All right, so we got that. All right, then the function f of x is equal to, actually, I'm going to have to call this one g of x first. All right, so g of x is, I'm going to just set this equal to e to the negative x squared. All right, so I'm going to put that in there. All right, so it's going to be e to the negative x squared. All right, then hit enter. All right. Then when you do an arc length, the integrand is going to be square root of 1 plus f prime. In this case, I'm going to use g prime squared. So I'm going to define integrand, which is f. I'm going to call it f of x. Then it's going to be a square root of, right, 1 plus, right, and g of x squared. So I'm going to square this, but I'm going to have to put the g prime of x, and then hit enter. Right? So we have that. All right, then we can just use the Simpsons rule. Integral is from 0 to 6, so we're going to have, right, so delta x over, maybe I'm going to just, let's see, I'm going to go to view, and then I'm going to turn off the graphics so that you can see this a little bit better. All right, so we have that. All right, then we're going to do, so delta x, so we're going to have to go to delta x over 3, because that's part of the Simpsons rule. All right, then we're going to have, first one is f of 0. All right, next one is delta x is 3 over 5, so I'm going to just keep on adding. We can actually do delta x too, but I'm going to just do it manually. So next one is 3 over 5, and then coefficient is 4. So 4 times f of 3 over 5 plus 2 times f of 6 over 5 plus 4 times f of 9 over 5, and then plus 2 times f of 12 over 5. So I'm just to keep on adding 3/5. Next one is 4 times f of 15 over 5, which is 3, and then plus 2 times f of 18 over 5, and plus 4 times f of 21 over 5, right? And next one is 2 times f of 24 over 5, and next one is 4 times f of 27 over 5, and I think this is the last one, f of 30 over 5, actually 5, which is 6. So maybe I can just put 6 there, so that starting from 0 to 6, right? And let's see, so coefficient 4, 2, 4, 2, 4, 2, 4, 2, 4, and 1, 1. All right, so we got everything correctly. Maybe I'm going to call this guy, so it's a Simpsons rule, so S of 10, and then equals to that, and then hit enter. All right, so we have a 6.31. I don't know what decimal places they want. There are 4 decimal places, so we have to change that. So go to setting, I think. Let's see. Go to setting. All right, so 4 decimal places, right? And then you have that. All right, so it came out to be 6.3115. So let's type in 6.3115. Right, let's type it in. All right, so we got the 6.3115. Right, let's check the answer. All right, I came back and looks like we got the first part correctly. Right, and to find the answer produced by a calculator. Right, so we're gonna have to go here. Right, so f is the integrand, so we just have to integrate. So integrate. So it's a function that's gonna be f, and starting number is 0 and to 6. Right, so this is what we're trying to approximate. So I'm gonna hit enter. Right, so it came out to be 6.2809. All right, so let's type it in. All right, so we have 6.2809. All right, let's check the answer. All right, it came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.